Right. Good morning.
Good morning.
Good morning. Yeah, right. Um, so last time we finished the hydrocarbons, ne? Hydrocarbon part,
Yeah,
ne?
yeah,
Um, and I asked to do the exercise also, ne?
yeah,
Right. Did you do that? Is that easy?
yeah. There was like one question that I wasn't sure of.
Uh huh. Okay, okay. Um, which one? Just tell me.
Um, I can find it and I'll show you like soon. Um, it's okay. I'll find it soon and then I'll show you.
Ah, right, right. It's okay. And another thing, uh, it's better if you send the answers to me, right? I mean, make a PDF and then if you send that, then I can check it, right? I guess it's better, right? After you finish that, just send it, right? Send it to the WhatsApp, make a PDF and scan it and scan the answers and send it. Then I'll mark it. Marking means, I mean, I can check it, right?
Okay,
And we can discuss it.
okay.
Right. Then today we have to start alcohols.
Mm-hmm.
Mm. Right now the topic alcohol. Alcohols. Alcohols and then subtopic physical properties of alcohol. Right, physical properties. Right. We talk about, I mean, as previous, right? We talk about boiling points and melting points, right? Those those are as a physical properties, right? So, what are the factors affect on physical properties of hydrocarbons? Which factor? Which factor we consider?
Um, m- like the properties, melting point, boiling point, solubility.
Yeah, yeah, those factors, right? I mean, um, for boiling points and melting point, which effect on? What are things
Um,
effect on? Huh?
the intermolecular forces.
Yeah, exactly, intermolecular forces, right? So that's what I want. Yeah, so same here in alcohols also, we have to focus on intermolecular forces, right? So we have to study the molecular structure, right? Consider the molecular structure to
Mm-hmm.
understand the intermolecular interactions, right? In hydrocarbons, there's only carbon and hydrogen, right? So therefore, what does the intermolecular forces there? Force the only dispersion forces or London forces, right? In
Yeah, yeah.
hydrocarbons. But here, when we come to alcohols, you already know what is alcohol, right? What is the group? It's OH, right?
Mm-hmm.
So when you see O, oxygen, you already know uh, what kind of intermolecular interaction should be there when hydrogen and oxygen present. It should be
Dispersion.
it's hydrogen bond, right? So this is the simplest alcohol, right? Simplest alcohol. So it shows hydrogen bonds, right? It shows hydrogen bond. Why? This oxygen, due to oxygen, this molecule is polar, right? This molecule is polar. So therefore, it has polar bonds and it shows hydrogen bond. So hydrogen bonds means, you know, it should have higher boiling and melting point than
Because it's strong.
yeah, it's strong, and I mean uh, they should have higher melting and boiling point than hydrocarbons, right? It should be in it, right? So write the first one and then boiling point. The first property, boiling point. Write down boiling point. Boiling point. Uh, write the first sentence. Write the first sentence.
Yeah.
First sentence. Due to the higher electronegativity, due to the higher electronegativity of oxygen, due to the higher electronegativity of oxygen, negativity of oxygen, alcohol contain polar bonds. Alcohol contain polar bond. Polar bond. Therefore,
Yeah.
therefore, it make hydrogen bonds. Therefore, it make hydrogen bonds. Hydrogen bonds between, make hydrogen bonds between
Yeah.
alcohol molecules. Alcohol molecules. Underline hydrogen bonds. Huh?
Okay.
Right. Let's draw diagram. Draw this diagram. This is slightly positive, slightly negative. Then right. So in alkanes and alkenes, right? Basically hydrocarbons, you know, chain length effect, ne? Remember?
Yeah. Yeah.
Chain length effect. So how it affect? When chain length increase,
melt,
the
boiling point
boiling point
increase.
increases because
Yeah.
it can make more
Forces.
dispersion forces, right? It can make
Yeah.
higher dispersion forces because the surface area increases when the
Mm-hmm.
molecular when carbon chain increases, right? So the same effect happen here, right?
Yeah.
When carbon chain increases, I mean nothing happened to the hydrogen bond, right? I mean there's only one OH, so it's make hydrogen bonds. That's it. But when carbon chain increases, the dispersion forces will be increased, right? Therefore, bigger hydrocarbon chains have higher melting and boiling point. It's a one thing, right?
Yeah.
It's similar to hydrocarbons, right? And another thing, remember, in hydrocarbons, when the chain is um, branched, right? When the chain become branched,
More increased boil. Yeah.
what happens when chain become branched in hydrocarbons? Branch chain, huh? When chain become branched, right?
It's harder
Something
to
like
pack.
hard to pack.
Pack.
Exactly, right? Hard to packed, right? Good. Hard to packed. So therefore, the dispersion forces are reduces, right? Dispersion forces are reduces, right?
So the
When it's
lower melting boiling point, which
lower
is
melting and boiling point, right? Same theory apply in here, right? So keep it in your mind. Huh? Um, so then I'll let you write that. Um, write as a point, right? Leave a rule and write down. When hydrocarbon chain increases, when hydrocarbon chain increases through a homologous series, through a homologous series, through a homologous series, when hydrocarbon chain increase through a homologous series,
mm-hmm.
boiling points will increases. Boiling point will increases. Boiling points will increases because because higher dispersion forces, because higher dispersion forces, right? Underline
Okay.
it. Higher dispersion, carbon chain increases, right? Um, right. So here branching means we can categorize alcohols into primary, secondary, tertiary, right? We did the same thing for hydrocarbons also, right? Let's say, let's take common one, I mean C4, C4H, program C, OH, right? This is the simplest, this is butanol, right? So you can change the structure keeping same formula, right? Called isomers, right? I mean by isomers. You can change it to, you can change the carbon chain also, you can change the position of the alcohol, both. Okay, right, like this one, right? This one is a secondary alcohol. Why?
because
the
it's only one.
OH bonded carbon, bonded to another two carbons, right? But here OH bonded carbon only bond with one carbon, right? So this is primary, this is secondary. Primary alcohol, right? This is secondary alcohol. Then how tertiary?
Three or more.
Three carbon should bond to this carbon. Right? This is tertiary alcohol. Draw this diagram. These structures.
Wait, so what's the definition of primary again?
Definition means there's no exact definition. Primary means this kind of structure, right? This carbon, I mean oxygen bonded carbon bonded
Yeah.
to one carbon, right? Here directly bonded to one carbon, right?
Oh, okay.
Here it oxygen bonded carbon directly bonded to two carbons, right? Here oxygen bonded carbon directly bonded to three carbon, right?
Oh, okay. Yeah.
You have to identify this when you see that, huh?
Okay.
Clear, eh?
Yeah.
So looking at this structure, you can see that properly, right? So this one looks like crowded, right? It's hard to
Yeah.
pack, right? This is structure, right? These two, I mean here this one also little bit harder than first one, right?
Yeah.
In a 3D structure, it's hard to make intermolecular interactions when it's crowded, right? That's what is
Yeah.
hard to pack, right? So you
Okay.
should have that concept. Because they asked to compare, right? They gave some molecules, right? When they gave some molecules and when they asked to compare the boiling points, right? So you have to compare, I think, right? You have to compare, right? They asked to arrange into increasing order or reducing order, right? Whatever. So you have to compare each other, right? Which one has highest, which one has lowest, right?
Yeah.
There are some exercises also. Um, then write down when we get when we consider the isomers of alcohol,
Mm-hmm.
write down,
Oh.
write down. When we consider the isomers of alcohol, as above, alcohols as above, as above. The branch carbon chain the branch carbon chain restrict the dispersion forces or reduce the dispersion forces. Reduce the dispersion forces. Restrict or reduce the dispersion forces. Therefore, tertiary alcohols has lower boiling point. Therefore, tertiary alcohols have lower boiling point. Continue. When we compare the primary alcohols and secondary alcohols.
Yeah.
Primary alcohols and secondary alcohols. Primary alcohols has a higher boiling point. Primary alcohols has a higher boiling point.
Yeah.
Due to higher dispersion forces.
Okay.
Right. Write in the next rule. This is similar to this concept works similar to hydrocarbons. This concept works similar to hydrocarbons. Right. Right, even in the listen so let's say you got a this thing can be this kind of thing. Let's say you have a bigger the bigger carbon chain, and in that carbon chain the end is branched, something like this. Let's say C, then here C, again C, right? This is not a tertiary one, right? This is still primary, but here some places in the carbon chain is branched. Again, that will cause to reduction of the boiling point, right? I said tertiary. Generally when it's become tertiary, we talk about the smaller ones, right? So most of the time when it's branched, it's become tertiary and secondary, right? Even it doesn't matter. Even the somewhere else in the carbon chain is branched, and it will cause to reduce the boiling point and melting point. Get the idea that it's all about dispersion forces, right? When molecules something arrange like this, right? How to say that? The space, right? It's all about the space, right? So
Yeah.
this is crowded, right? It's become crowded, so it's hard to make dispersion forces, right?
Yeah.
Enough. Then how about the solubility? So from the beginning I said this is a polar, right? It has polar bonds, ne? It has
Yeah.
polar bonds, right? It has polar bonds means it's a polar compound, right? Alcohol is a polar compound, right? I mean, you know that anything, right? When you see alcohol, I mean, alcohol bottles, right? You can't see two layers, right? You can see a mixed one, right? Yeah.
Yeah.
You see any, right? Yeah. Right? You can't see two layers, right? If you see two layers, then it doesn't dissolve, right? But
Yeah.
we can see, I mean, just a mixture, right?
Yeah.
Dissolved, right? So this thing dissolved in water, but the problem arises when carbon chain become longer, right? You know that R group, we call this carbon chain as R group, right? You know that R group. When R group becomes bigger, you know R groups are hydrophobic,
Yeah.
right?
Perfect.
R
Yeah.
groups are hydrophobic, right? So therefore, when R group getting bigger, solubility of the alcohols reduces, right? It drastically reduces, right? There is a table also. If you have a textbook, turn page number 322. There is a table, right? You can see a table, solubility and the chain length, right? So the butanol, solubility of butanol C4H C4H9OH, solubility is 7.9 grams, right? 7.9 grams per 100 grams of water, right? 100 grams of water, right? And each one, then C4H11, C4H11OH, it reduced to 2.3 grams per 100 grams per H2O, right? Look at the solubility, yeah? 7.9 to 2.3. Just after, sorry, C5, this is C5, not 4, C5, right? Just after one CH2 increases, right? And next one C6H13, isn't it? Yeah, C6, yeah. OH, this one 0.6 grams, 100 grams H2, right? Look at the difference, right? Reduction drastically reduces, right? So actually, methane, I mean methanol, ethanol, right? Propanol also. This one also, I mean, you can say it's dissolved, right? I mean, after that, I mean, higher than carbon 5, 6, actually it doesn't dissolve in the water, right? It's become a non-polar compound, right? Because that R groups become dominant, because I mean R group getting bigger and bigger, right? So then it's become dominant, right? This one's OH group is dominant, and I mean to dissolve the whole molecule, that one OH is enough, right? But when it's getting bigger, OH can't handle that, right?
Yeah.
That's what happens. So this one, yeah, after 6, 7, then it's getting immiscible, right? Right. You know how things dissolve in water, right?
Yeah.
They are making hydrogen bonds with water, right? That's what
Yeah.
happened. Whatever, right? Even ionic compound also, ionic compound doesn't make hydrogen bonds, but they are making ionic ion ion dipole interactions, right? Anyhow, dissolving in a water or another liquid, the meaning is they make intermolecular interactions, right? You have to
Yeah.
understand it in a molecular level, right?
Yeah.
They have to make intermolecular interactions. If they can't make intermolecular interactions, they don't dissolve, right?
Yeah.
That's the theory, right? That's why polar can't dissolve in non-polar, right? They can't make any bond, right?
Yeah.
Right? Polar one doesn't make doesn't depend on dispersion process, right?
Yeah.
So non-polar one only make dispersion, right? Then leave a rule and write down alcohols that has shorter hydrocarbon. Write down alcohols that has shorter hydrocarbon chain. Alcohols that has shorter hydrocarbon chains. Well dissolved in water. Well dissolved in water. Or dissolve well in water, whatever, right? Dissolve well or well dissolved, right? In water. Write down.
Yeah.
Get the idea. And write down. Full stop. When carbon chain increases, solubility reduces. Solubility reduces. Solubility reduces because R group. Because R groups. No, don't say R group. Because carbon. Because hydrocarbon chain. Because hydrocarbon chain. Because hydrocarbon chain is hydrophobic. Hydrocarbon chain is hydrophobic. Because hydrocarbon chain is hydrophobic. Yeah. Let's write this one. Draw it. Draw this structure. This is
Okay.
right. Right. So after 5, 6, as I said, the solubility, I mean, almost getting 0, right? After 6, yeah. Then bigger hydrocarbons dissolve in where? The bigger hydrocarbons should dissolve in non-polar compounds, right? So that means they should dissolve in organic compounds, right? Smaller hydrocarbons dissolve in water, and the bigger hydrocarbons dissolve well in organic solvents. Organic means basically non-polar solvents. So write down it as a point. Bigger alcohols, bigger alcohols, bigger alcohols, bigger alcohols
Yeah.
are more soluble in, bigger alcohols are more soluble in organic solvents. Write down. Bigger alcohols, bigger alcohols are more soluble in organic solvents. Right, it's enough. Right. Then additional things in it, right? So there's a vitamin C. Is it vitamin C? No, sorry, vitamin A. Vitamin A. Vitamin A and vitamin C, right? So that vitamins contain hydroxyl groups, right? Those are bigger organic molecules, right? Okay, then so we talk about the physical properties and then we have to talk about chemical properties, right?
Mm-hmm.
So write down a subtopic: production of alcohol. 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 There are several ways to produce alcohol, right? We talk about organic reactions. Right. One of the common ways we can replace alcohol we can replace OH group, sorry, I mean the Cl group by OH,
Mm-hmm.
right? No need to draw weight, right? Wait, this is OH, right? Right. This is the initial reaction that we're going to talk about, right?
Yeah.
So here what happened? OH replaced the chlorine or halogen, right? This we can do it for halogen, right? So did we talk about the names, the types of the reaction, substitution, and did we?
Yeah.
I said that, ne?
Yeah.
So substitution and addition, ne?
Yeah. Mm-hmm.
Basically. So what is called addition? What happened during the addition? In addition, okay, tell me. Addition,
Uh,
addition reaction. What happened basically? I'm asking
when
some questions,
yeah. For addition, like the carbon double bond becomes single bonds.
Yeah, exactly.
Yeah.
Yeah. Yeah, it's mostly for carbon and it's valid for any double bond, right? So we don't
Yeah.
remove anything, right? We don't remove anything.
Yeah.
When double or triple bonds present, we just add some more, right? Break that double or triple bond, and then
Yeah.
we add something, right? So that's what you call addition, right?
Yeah.
So substitution means it's a kind of replace, right? Replacing. We replacing one part
One add
from another
part
one,
with a
right?
different one. Yeah.
Yeah, part, yeah, exactly. So here what we do, we just replace Cl by OH, right? So this is a substitution, right? This is a
Yeah.
substitution reaction, and this is a common way to produce alcohol, right?
Mm-hmm. Yeah.
So then what will happen? So you don't have that mechanism, right? Yeah, we don't have that mechanism. Here it's simple. Your syllabus is easy, and nothing complicated. If you right, just replace, right?
Mm-hmm.
Um, so we can produce alcohols, I mean, by replacing Cl. We can provide OH minus as hydroxide. Okay, we can provide OH minus as hydroxide. So then it's just replace, right? It can replace because this bond is it's kind of a polar bond, right? Because of the electronegativity. So this bond break towards the Cl and it just Cl leave, and then oxygen can attack, right? OH can attack, right? You don't have that mechanism. I haven't tried it. So that's what happened basically.
Yeah.
So write down the first one, first reaction. This is no, right? Here we talk about the production of alcohol. The
Yeah.
first way, right? So write this as a small subtopic first. Put the question number one: substitution reactions of halo alcohol. Substitution reactions of halo alkanes. This is the first way to produce alcohol. Substitution reactions of halo alkanes. This is the first way, yeah. Okay, then write down sentence. A substitution reaction occurs. A
Yeah.
substitution reaction occurs. A substitution reaction occurs when an atom or functional group in a molecule is replaced is replaced or substituted by another atom or group. Another atom or group. Right. Here this bond is polar, right? This bond is polar. Right? Therefore, it can leave when it's attacked. Right? So that's what happened. Leave a rule and write down. CCl bond, write it like this. CCl bond in chloromethane, CCl bond in chloromethane. CCl bond in chloromethane is polar. This electronegative Cl carries partially negative charge. Partial negative charge. When partially negative charge attack to carbon, in next rule, continue next. Don't leave the rule. Next rule. When partially negative charge, this one. When partially negative charge attack to carbon. When partially negative charge attack to carbon,
Yeah.
attack to carbon.
Attach or attack? Attract.
Attack to carbon. Attacking, we call it attacking, right? Attack to carbon.
Wait, like ATTACK?
Yeah, that attack, yeah. Normal attack, yeah, that attack, right? We call it attack, right? Not beating, I mean, that's how we call it, right? Attacking, right? Attack. Cl can leave Cl can leave as a negative ion. Cl can leave as a negatively, yeah, Cl can leave as a negatively charged species. Write it like that. Cl can leave as a negatively charged species. Cl can leave as a negatively charged species.
Okay.
Okay, write this write this equation. You don't need to remember this arrow pathways, right? They don't ask, right? But just learning.
Okay.
It's clear what happened. No?
Okay.
Right. Then we can write this reaction for chloroethene also. Alright. Here it's OH minus, right? So
Yeah.
we can make alcohols from halogens, halogens using water also, right? But in that case we have to use catalyst, right? Here we directly use OH minus. We can do it from water with the presence of catalyst. Clear? With the presence
Yeah.
of catalyst. Here, how do we send the OH minus? As a base, right? Especially we use sodium hydroxide, potassium hydroxide, basically, right? You can do it. So the next one, the same thing with water, but it's required a catalyst. Okay.
Yeah.
Um, write down a sentence. Leave a rule and write down a sentence. Haloalkanes produce haloalkanes produce haloalkanes produce alcohols. Haloalkanes produce alcohols. Haloalkanes produce alcohols by reacting water water
Yeah.
with the presence of catalyst. With the presence of catalyst. With the presence of catalyst. And then let's write down CC Cl. Write down the equation. This one also substitution reaction. Huh?
Okay.
By looking at the equation, or basically reaction, you have to identify whether it's substitution or addition, right?
Oh, okay.
Finish. Ne? Right. Then write down next one, next type of reaction. Formation of, sorry, not formation, right? Here we talk about production of alcohol. First one we talk about substitution reactions of haloalkanes. Then the second one, fermentation of carbohydrates. It's a next type, next way of production, next way of producing alcohols. Fermentation of carbohydrates. Fermentation of carbohydrates. Right? You already familiar with this thing, right? What is this? Simply, right? We add some microbes into the what kind of carbohydrate we use generally? This is basically alcohol production, right? Alcohol. I mean, alcohol means that ethyl alcohol. You know that industrial production, right?
Yeah.
We get carbohydrate and we add, especially yeast, right? And
Yeah.
what will happen? They ferment it and produce ethyl alcohol and carbon dioxide, right?
Yeah.
So that reaction used in mainly, for alcohol production as industry and drinking alcohol, and where in other hand we use the same reaction in bakery industry, right? Bakery is also right. Why? They need carbon dioxide, right? Bakery need carbon dioxide. um, Drinking alcohol, right? So it's alcohol. So here we basically ferment simple sugars, right? Simple sugars, right? Especially glucose and sucrose, right? Those are the sugars that we use. So this is very simple, right? The main microbe that we use, yeast, right? You can do it at home. Simple one. I guess it's already in biology also, right? It may in biology, and some bacteria can do the same thing. Yeah. The final product, I mean, it's depend on the microbe and the products, not products, the material that you ferment, right? The carbohydrate and the temperature also, right? Those factors will affect on the final output, right? So that's why, alcohols, drinking alcohols, um, they have different taste. I'm not alcohol. I'm not drinker, right? The smells and those things, right? Different colors, right? You know that beer. They produce beer using barley, right? They produce beer using barley, and wine basically grapes and
Right.
fruits, right?
Yeah.
So it had different taste, right? So depend on the material. Alcohol is alcohol, ethyl alcohol is ethyl alcohol, but it produces some other things also, right?
Yeah.
And they have to use different condition, right? Different countries, different regions, different companies use their own procedures, right? Most of the time, those are kind of a secrets, right? So that's how it's happened. So here, it's basically, we have to remember what happened. It's I'll write it. So it's basically convert sugar, let's say glucose into alcohol, ethyl alcohol and carbon dioxide, right? So in biology, actually in the biology,
Yeah.
as you know, alcohol is a toxic, right? Alcohol is a
Yeah.
toxic. Even ethyl alcohol is a toxic, right? The easiest way to explain it, why, I mean, you know, I mean, it's a production, it's a byproduct of their respiration, right? It's a byproduct of their respiration. So they produce alcohol as the byproduct of their respiration. I mean, why do they uh, do that kind of respiration? When the oxygen level is reduces, right? So
Anaerobic.
yeah, they are doing we call it
Anaerobic.
anaerobic respiration, right? It's called
Yeah.
anaerobic respiration. This is the biology part. So they release it from their body because it's toxic, right? Even that bacteria doesn't need that, right? So then we extract it and then we drink it, right? it's a it's a waste of bacteria, right? So uh, and I mean the factors, right? So still in the factors, um, yeah, another thing, um, purification process also affect, right? Purification, alcohol purification, I mean, some alcohols, you know, alcohol that has higher percentages, I mean, like whiskey, brandy, right? What are the brands? I don't know, I mean vodka, right? So that kind of, I mean, some unknown ones also, right? uh, More than, I mean, more than 20, I mean 15, 20, those are processed ones, right? That means they extract alcohol, right?
Yeah.
Alcohol means, here I'm talking about ethyl alcohol, right? So they
Mm-hmm.
extract ethyl alcohol and they mix it, right?
Yeah.
There's a extracting process also, right? That's how they make that stronger ones. Otherwise,
Yeah.
it's not natural. It's not natural. Natural ones are beer, beer. I mean that the light ones, light drinks,
Mm-hmm.
beer, wine, right? So wine maximum, I guess it goes to 13% or 14%. I mean, after
Yeah.
that, what happened? Why
13.5.
what? 13?
Yeah. 13.5.
Ah, right. You know, I don't know you. You said that. I don't know. Then 13 point. Okay. Then it doesn't reach higher than that because that microbes will die, right?
Yeah.
Alcohol is toxic and then microbes will die after that concentration. It's a concentration in 13.5 means.
Yeah.
So naturally we can't reach higher than that. Then
Mm-hmm.
after that we have to extract alcohol, ethyl alcohol, right?
Yeah.
Alcohol is, we use alcohol to clean our hands, right? That
Yeah.
kind of
Hand
thing,
sanitizer.
alcohol, right? Hand sanitizer. Um, they show the, I mean, huge process eating alcohol. You can, using this knowledge, you can make your own one at home, right? If you
Yeah.
study this part, right? You can make own alcohol at home. I think the most important parts. So write down fermentation of carbohydrate, and actually think, uh, this is a this one is one of the oldest industry, right? One of the oldest industry, right? You know, there are some oldest jobs in this world, right? What are the oldest jobs? This is one of the oldest industry, right? I mean, people found Mesopotamian or that kind of civilization. The alcohol belongs to them, I guess, which is older than 4,000 or 6,000 years ago, right?
Yeah.
That much earlier, right? At that time, we know nothing, right? I mean, human civilization, I mean, it doesn't develop, but we had alcohol, right?
Yeah.
Right? Then, what are the oldest, what are the oldest jobs in this world? Oldest jobs.
Winemaking.
Okay, wine making is, I mean, I said it's take as industry, right? So it's
Okay.
industry, right?
Yeah.
Jobs, basic jobs, services.
Mm.
What are the oldest services?
Like making tools.
Making tools. Okay, what else? Early. These are the earliest
Farming.
jobs.
Farming.
Farming. Yeah, okay, it's good. Farming, and we had to do that. Everyone did farming. Doctors were there, right?
Yeah.
early. Yeah, doctors. I mean, they don't exactly doctors, but there are some people they are treating for med. I mean, they give medicine, right?
Yeah.
And teachers were there, right? They have trained them, right? There's another one, right? That's doing by woman. I don't say that. Think it. something, something doing by woman. Like those are the most, I mean, oldest services, and I mean, wine production, wine, and that farming. Those are industry actually, right? Those things were there, right? And that's it, nothing else, right? Then constructions also. I mean, there's no any construction at that time. Very simple life, right? They make alcohol and then drink, right? And then they farming, and that's it. Okay, write down. Ethanol is ethanol is by far the most common alcohol. Ethanol is by far the most common alcohol. Most common alcohol. Most common alcohol to be made using fermentation. To be made using fermentation. To be made using fermentation by microorganisms. By microorganisms such as yeast, yeast and bacteria. Yeast and bacteria. Right? Then other alcohols are very toxic. Huh? Keep it
Yeah.
in your mind. Other alcohol we can't drink. Right? Methanol is highly toxic. Methanol, and you know, it sometimes it causes to people die because when they make alcohol, when they try to make alcohol at home, sometimes it produce methanol, right? If that fermentation doesn't happen properly, I guess that happened due to unknown bacteria, right? I don't know what happened, but anyhow, sometimes that alcohol contain methanol also, right?
Yeah.
Then sometimes people will die when they get, you know, I mean, in here Sri Lanka we call, I mean, the village one. You have you heard about Kasipu or something? You don't know,
Yeah.
right? You
I know.
Australian, right? You don't. You
Yeah,
know
but I know.
Kasipu?
Yeah.
How do you know Kasipu? Right, right. I mean, anyhow, right? So we have Kasipu, right? So very dangerous because I mean, no one checked that. Maybe it contained methanol. Even smaller, it's directly affect on your neuron system. Right? Ethyl alcohol also affect on neuron system. That's why you got dizzy, right? When you drink
Yeah.
alcohol you got dizzy, ne? Why? It directly had attack on neuron system. Methanol, far beyond that ethyl alcohol, it's highly toxic on your brain and neuron system, right?
Yeah.
So sometimes it's this early incident, I mean, more than 200 people die in India, right?
Yeah.
I haven't remember exact story, but I mean that kind of things happen in the world, right? They just make their own one and then they drink. If it's contain methanol, I mean they don't know how to separate methanol and ethanol. They can understand. I mean, no any difference. You think the same strength, same smell, right? Just one carbon, right? One CH2, right? One
Yeah.
CH difference of one CH2 part, right?
Mm-hmm.
It may that one CH2 part make that much difference, right?
Yeah. Yeah.
Right. Um, write down next point. Next point. Methanol is very toxic for human. Methanol is very toxic for human than ethanol. Methanol is very toxic for human than ethanol.
Mm-hmm.
Methanol is very toxic for human than methanol.
Yeah.
Right. Next point. Next point.
Mm-hmm.
There are many different processes. There are many different processes used in fermentation. There are many different processes used in fermentation. Used in fermentation. Used in fermentation. And 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 these vary. These varies depending on. These vary depending on. Depending on. Down by down. Down by down.
Yeah.
First one. The available starting material. The available starting material. First one. The available starting material.
Mm-hmm.
Next one. Mixture of yeast or bacteria used. Mixture of yeast or bacteria used. Second one. Next one. Fermentation temperature. Fermentation temperature. Fermentation temperature. Next one. Traditional steps. Traditional steps and ingredients. Traditional steps and give me a second.
Okay.
Right, next one. Whether the process sealed or open. Next one. Whether the process sealed or open. Whether the process is sealed or open. Next one. Purification process. Purification process. Purification process. Next, last one. Last one. Intended use of the process. Intended use of the process. Right. So as we discussed, so their alcohol production steps completely different from each other, right?
Yeah.
It's different from making. I mean, then let's say when they, sake. The Japanese, they have sake, right? So they use rice, right? It's different, right? I guess they just boil it and then let it that kind of
Yeah.
process, right? Then barley, I don't know. I mean, I guess they just let it to germinate and then grind it or something, right? Different processes, right? And things like sugarcane, you can directly use it because it directly contain sucrose, right? It's easy, I guess. And fruits, I guess they just chop it and then let it ferment, right? The
Yeah.
processes are different when you have the complex carbohydrates. I guess complex means that, I mean, rice have starch, ne? Fruits basically have sugars, basic sugars, right?
Mm-hmm.
So then write down fermentation reaction is important, right? So this is what happened basically. Alcohol, they take sugar, I mean glucose, C6H12 or 6, and it convert into 2CH3 CH2 OH plus 2CO2. Write it down.
Okay.
Generally, the temperatures they use, general temperatures, Celsius 15 to 35, right? Don't need to memorize those things, right? That 15, 15 to 35, as you know, I mean, when the temperature increases, that fermentation speed, fermentation rate will increase, but you know, these reactions based on enzymes, you know, biochemical reactions, right? These,
Mm-hmm.
these reactions, these things happen inside of organisms, right? So these are biochemical reactions.
Yeah.
In what happened when you increase the temperature of biochemical reaction? How it differ from normal reaction?
Speeds up.
Huh? Yeah, it's based on
It's
enzymes, right? So when you
so
increase the
it's
huh?
speeds up.
Yeah,
It
it's
goes
speed up.
fast. Yeah.
Then after that, is it continuously speed up?
No.
It will speed up to some temperature,
Yeah.
and you know, these are based on enzymes, right? Enzyme means what? Your biology student name
These
enzyme.
are biological catalysts.
Okay, how it's made? Enzyme.
Um.
Proteins. Enzymes
Yeah.
based on
Oh
proteins.
yeah, by like
Yeah,
folded
right.
proteins into 3D
Right.
structure. Yeah.
Right, right. So then, what happened to protein when it's under higher temperature?
Denatures.
We call it denature, eh? Right?
Yeah.
Protein denature, right?
Yeah.
The structure is change. Protein, I
Yeah.
mean, this enzyme structure will change, right? When you increase the temperature. Uh, Not generally, but after some point, right? After
Mhm.
some temperature.
After the optimal temperature, the
Yeah,
shape
exactly.
changes.
Yeah, then the shape change, right? Um, then what happened? The reaction will stop, right? Because that these are acting as a catalyst. That catalyst destroy, right?
Mm-hmm.
So therefore, um, we can increase. I mean, generally we can increase that protein DNA start. I guess generally 45, 50. I guess around 50, 50 Celsius. I haven't remember anything. I'm not biology student, right? I'm a biology teacher, right? So I forgot biology. Anyhow, that's what happened, right? That catalyst will destroy. So therefore, we have to keep this kind of range, right?
Yeah.
Don't think we can increase the temperature and getting higher yield, right? We can. It has a limit, right?
Mm-hmm.
Increasing temperature and getting higher yield, it has a limit. So these are the temperatures, and then separation. You know this how to separate ethyl alcohol. How to separate ethyl alcohol from the mixture?
You can do fractional distillation.
Fractional distillation, exactly. Fractional distillation, right? Fractional distillation. We use fractional distillation for what kind of situation?
Um,
We use fractional
just
distillation though when your mixture contain more than single volatile component, more than
oh yeah.
one single component, right? Two, three, four, five, right?
Yeah, so
Then we
it
have to go with,
separates it in
yeah.
like yeah, in layers. Like
What
the
did you say?
volatile ones are separated.
Yeah, the volatile ones separated, right? So
Yeah.
we use that method. We have to use that method when your mixture contain more than one volatile substances, right? And when both, I mean, let's say two volatile substances, then both will evaporate, right? So in that kind of
Yeah.
situation, we go with fractional distillation, right? And what is simple distillation? We have used simple
Um.
distillation. In simple distillation, it's different from fractional one because simple distillation it's contain only one volatile component, right? It's contain one. Example, we separate sea water. I mean, water from the sea.
Mm-hmm.
Generally, sea contain only one volatile component, which is water, right? Salt doesn't volatile, right? So then we can easily separate water. But here,
Mm-hmm.
when we come to alcohol, water will evaporate, and ethyl alcohol also vaporize, right? Evaporate or vaporize, right?
Yeah.
Therefore, it's different, right? We have to use fractional distillation.
Yeah.
Fractional distillation, I mean, it's used in, we have to talk about it later, fractional distillation. Right. Here, there is a structure. Um, they don't ask it, ne? Just write down, write, write the way we separate. Alcohol separate from the final mixture. Alcohol separate from the final mixture using alcohol separate from the final mixture using fractional distillation. Using fractional distillation. Right. Remember, using this fractional distillation method, we can't get 100% pure alcohol la, because it, I mean, in the vapor, I mean, that vapor mixture, you know, I mean, use this kind of one, right? This is Liebig condenser, right? Liebig condenser, and then another general question, right? Why do we put water into the Liebig condenser from the bottom hole? Do you know Liebig condenser, right?
No.
Then I have to explain it. I thought you already know that. You said fractional distillation and
Yeah, I know because we did it in year 11, like the different separation methods, like
right.
evaporation and like filtration and stuff like that. But we didn't go deeply into the parts of the process and
Right
stuff.
here, this one called Liebig condenser, right? So what happened? The function of the Liebig condenser here, it generate vapor, right? So this Liebig condenser cool down the vapor and send the liquid. That's what happened. In the Liebig condenser, there are two holes, right? I mean, water in and water out, right? We send the water from the bottom hole. The reason, when we send the water from the bottom hole, it will fill the uh, I mean, the structure of the Liebig condenser, the inner tube covered by outer tube, right? So that's how it's cooled down, right? The inner tube contain vapor. So to convert vapor into liquid, the outer one should filled by water and then just cool down, right? To do that, in order to do that, we should send the water into this hole, because when we send it like that, it will fill, right? It will cover the whole tube, right? The water can cover the whole tube and then take out the water. But what will happen if we send water from the top hole, I mean this hole, if we send it like that, it doesn't fill, right? Before it fill, water just go out, right? It
Yeah.
doesn't fill. When there's a hole like this, when you send the hole and when you send the water into this kind of hole, it just go back, I mean, just go away without filling. But when you send the water from the bottom, it will fill and then leave. Understood?
Yeah. Yeah.
It's like filling water from the bottom hole. Make a bottom hole and then it will fill and then leave, right? But if you put the water from the top hole, it will leave before filled, right? That's the idea,
Yeah.
right? So then this Liebig condenser cool down the vapor, and then we can get water alcohol mixture. Um, but we can't get exact 100% alcohol. It's hard means, I mean, it's kind of impossible.
Mm-hmm.
So because even at lower temperature, this gas mix, I mean, alcohol is volatile than water. So therefore we always keep lower temperature. We don't
Yeah.
let water boil, right? We don't let water to boil. We need alcohol, right? We let alcohol to boil. And even at lower temperature, this vapor contains some amount of water, right? So therefore
Mm-hmm.
we have to, therefore we can, therefore our final sample contains some amount of water. So to increase the accuracy, what people do, we have to again send the output final product through a distillation process, right? It's still, I mean, we can't get 100%, right? But we can get more than 90, right?
Mm-hmm.
That's what we do. Separate, and then final mix again we can distillize, right? uh, the what happened there, it's under equilibrium, right? There is a low, remember something wrote in my board, right, in the beginning, right? Raoult's law or something, right? So these things can explain using that theory. I mean, you will learn it at university, right?
Oh,
Not here. That part isn't here. You don't know Raoult's law, right?
no.
What are the things in the equilibrium? Basic acid base, pH.
Yeah.
What are the things in the equilibrium part in your syllabus?
What do you mean things? Oh, like content in the
Yeah, content.
equilibrium. Oh, like Le Chatelier's principle.
Lecturely, and then I mean KCKP.
Yeah. KSP, KC,
Uh huh.
KEQ.
It doesn't have something called Raoult's law, ne?
No,
Phase equilibrium or something.
no.
No, ne? Right. So you don't need that, but anyhow, just keep it in your mind. It's hard to achieve 100% accuracy, right? But
Okay.
we can get more than 90. So this condenser, it's a common knowledge, right? Liebig condenser, the water inlet and outlet, right? So yeah, that's it, I think, right? Basic theories. I mean, just read that part if you need. Nothing to write down. Write another sentence.
Yeah.
Another point. It's hard to achieve. It's hard to achieve 100% pure alcohol. It's hard to achieve 100% pure alcohol from aqueous alcohol mixture. It's hard to achieve. Write down. It's hard to
Yeah.
achieve 100% pure alcohol from aqueous alcohol mixture. Aqueous alcohol mixture. Aqueous alcohol mixture. Right. Yeah, that's it. Then write down reactions of alcohol. Reactions of alcohols. Uh, shall we get a 5 minute break?
Okay.
Okay. Come at 8:36. Go get a water break. Take a water break. Go, just go. And go.
I can't hear you.
Right. Write down reactions of alcohols. Reactions of alcohols. Then the first one, combustion of alcohol. Combustion of alcohol. Right. We already know alcohol is flammable, right? Alcohol is flammable, highly flammable, especially the small alcohols, right? And nowadays, there are some vehicles that using alcohols. I said that it's using alcohol, right? I mean, some of them mix using gasoline mixture, and
Mhm.
there are some engine that can only completely run on ethanol, right?
Yeah.
Ethanol, um, ethanol is a good fuel, right? Because it's sustainable. We can produce it, right? It doesn't over, right? So therefore,
Mhm.
people, I mean, they just focus on that kind of solutions, right? Um, so anyhow, it's very flammable and it's completely burned down. So when it's burned, it's produce carbon dioxide and water. I mean, complete combustion. Okay. See, there are some
Mhm.
restaurants and bars. I mean, they just show some stunts. I mean, using flame,
Yeah.
they just burn the food right in front of you, right, as a presentation, right? Just
Mhm.
they just serve with the flame sometimes. Have you seen? I
Yeah.
haven't did that kind of restaurant, but I saw that, right? They just
Yeah.
serve with the flame, right?
Yeah.
So what they use alcohol, right? They can't use
Mhm.
gasoline or something, right? Right?
Mhm.
They just use alcohol, right? It's not
Mhm.
harmful, right? If they burn with alcohol, you can't eat it.
Mhm.
Right. Write down, write down. Alcohols can easily burn as hydrocarbons. Alcohol can easily burn as hydrocarbons. Alcohol can easily burn as hydrocarbons. Hydrocarbons. This reaction is highly exothermic. This reaction is highly exothermic. This reaction is highly exothermic. And then write the equation. This reaction is highly exothermic, and then write the equation.
Okay.
Right. You are taking the notes properly, right?
Yeah. Yeah.
Taking notes okay, right? I mean, is this the first time taking notes? No, ne? I mean, you said, I mean, your school, you don't write notes and you just copy the presentation and those things, right?
Yeah.
I'm giving small notes. I mean, then you don't need to make any notes, and then you can study directly, right? Right. Then next one, oxidation of alcohols. Next type, oxidation of alcohols. Oxidation of alcohols. Oxidation of alcohol. Oxidation of alcohols.
Yeah.
Right. What is oxidation? First of all, what is oxidation?
Uh,
Basic idea. What is oxidation?
Oxidation is like um
Just say
when
it in your own word. It doesn't matter, right?
it's like when you lose electrons.
Okay. Mm-hmm. It's a one perspective. And what else? There are several ways to explain oxidation. The basic one is uh, removing electrons. Yeah.
Yeah.
And you know that in a molecule, these atoms have oxidation number, right?
Mm-hmm.
Atoms have oxidation number. So during oxidation, that oxidation number will increase, right?
Mm-hmm.
That oxidation number will increase. In other hand, you can say um, oxidation means combining with oxygen, right? Oxidation means combining with oxygen, right? The
Yeah.
reduction, you can say gaining electrons,
Yeah.
gaining electrons, or reducing the oxidation number, right?
Mm-hmm.
Or you can say removing oxygen, right? You can explain using those terms, right? Get the idea. So here we talk about oxidation of alcohol. So first we should, let's take a basic alcohol. R means R group, right? This is
Mm-hmm.
alcohol, this is right. The carbon chain, it doesn't matter, right? It doesn't affect on the oxidation, right? Here we talk focus on the group, ne, right?
Yeah.
Added group, ne, right? Here, what you call that? Added group, ne. So this
Yeah.
carbon and oxygen, this is the main part, right? It doesn't matter, right? Whatever R, right? It doesn't matter, right? We talk about only this side, right? So can you find the oxidation number of carbon here? What is the oxidation number of carbon?
Um.
We count the oxidation number. There are several ways, right? So you can count the oxidation number when carbon, whatever, when something bonded with higher electronegative atom, higher electronegative atom, the higher electronegative atom get -1, right?
Yeah.
Higher electronegative atom get -1. Here, what is the oxidation number of oxygen then? Here it's bonded with oxygen and hydrogen and carbon. So
Yeah.
hydrogen, oxygen has second highest electronegativity, so therefore its oxidation number is -2. Actually, oxygen is always -2, except there is only one, two places its oxidation number change. I mean, when it's bonded with, oxygen, oxygen in O2, right? In O2,
Mm-hmm.
what is the oxidation number of oxygen? When it's bonded with its same atom, there's
Yeah.
no any electronegativity difference, right? Therefore, oxygen bonded with oxygen, oxidation number is 0 in that case, right? Keep it in your mind. This is all about electronegativity. The
Are
highest
they gonna
electronegativity.
ask us about
Huh?
this? Are they gonna ask us about this?
No. Um to understand the oxidation concept, you need that knowledge, right? They don't ask about this one, right?
Mm-hmm.
So you should have a basic idea how it's work, right? Electronegativity, highest electronegativity shown by fluorine, and then
Yeah.
oxygen, and then chlorine, chlorine and nitrogen very similar, right?
Mm-hmm.
So when oxygen bonded with oxygen, what will happen? Its oxidation number is 0.
Yeah.
Oxidation number is 0. Why? No any electronegativity difference, right? No any negativity difference, right? Here, oxygen bonded with carbon and hydrogen, their electronegativity is lower than oxygen, right? Therefore, oxygen will get -2. So oxidation
Yeah.
number of oxygen is -2, right?
Mm-hmm.
So what I said, it's oxygen always get -2 except several instances. One is when oxygen bonded with oxygen, right?
Yeah.
Then
Yeah.
there's another time oxygen get plus. There's a one instance oxygen can get +2. Can you guess that? That is OF2. Here fluorine is what? Fluorine is electronegative than oxygen. Therefore fluorine get -1 and oxygen get -1, -1, right? This one. And -1, -1, -2, right?
Okay.
So that's how that oxidation, I mean, that's how we find the oxidation number of the atom, right?
Yeah.
So here then tell me the oxidation number of this carbon. Here this carbon bonded with, I mean, other side, let's say there is another carbon, right? R group means another carbon, right? Okay, then likewise. Then CC, no any electronegative difference. Therefore, no any changes happen due to this bond. And hydrogen has lower electronegativity. Therefore, carbon will get -1, -1. Due to oxygen, carbon will get +1. Right?
Okay.
So, what is the final oxidation number of carbon now? +1, -1 cut off, and
Yeah. So
only -1 will
remain.
uh,
Yeah.
remain. Right, okay. And the final one is -1. You can do it by, I mean, හිතලා ලියන්නත් පුළුවන් නිකන් හරි. Then I said oxidation, right? Oxidation, right? We can use different chemicals, right? I'll explain what are the chemicals. So here we should know what happened during this oxidation. So oxidation number of the carbon should increase.
Yeah.
That's what should happen, right? Oxidation number of this carbon is -1, then it should increase. Increasing means it should getting positive, right? It should get positive. So there are two steps of oxidizing alcohols, right? Here I am talking about primary alcohol, because primary, I mean, the things get changed when you goes to secondary and tertiary, I mean, little bit primary, right? So the one step is you can convert it into aldehyde. You can convert it into aldehyde. Look at the oxidation number now. What is the oxidation number? Oxidation number of the carbon. Now carbon bond with oxygen via two oxygen bonds, ne?
Yeah.
Right? Then CC bond doesn't affect, only one hydrogen. So now what is the oxidation number? +2 due to oxygen bond, -1 due to hydrogen bond. What is the final one then? Final one plus
+1.
+1. So we can see oxidation number increases from -1 to +1, right?
Yeah.
Oxidation. Then there's another level. This is aldehyde. Then you can oxidize it furthermore, right? It's still +1, right? I mean, now you can think, right? How much you can oxidize this compound, this carbon, until it's reach its maximum oxidation number. What is the maximum oxidation number? +4. +4, but +4 means what? CO2.
Yeah.
Right? We already did that, ne? Here, me. This one. That's combustion, right? If you, it's kind of, I mean, combustion means that thing, right? Oxidation, right? It's oxidation generally. So here we don't oxidize up to this one, this level, but we can oxidize up to +3. What will happen? You can make, sorry, +3, not +3, I mean +2. R, you can convert this one into R, CH2, C double bond O. Oh yeah, +3, +3. This one. So what is the oxidation number now?
Now it's yeah.
CC bond, nothing, right? This one, 2, 3 plus 3.
Okay.
Clear?
Yeah.
This is what happened during oxidizing, right?
Okay.
So we can use some compounds. I'll explain about the compounds, right? Yeah. So keep it in your mind. This combustion also kind of a oxidation, na? Right?
Yeah.
It's a oxidation thing, right? That's the most common oxidation, right? And we call redox reactions also redox. I mean oxidation and reduction reactions. We call them as redox reactions, right?
Yeah.
So these are redox reactions. Write down under oxidation reaction. The combustion of alcohol, the combustion of alcohol, the combustion of alcohol classified as oxidation reaction. Um, uh, yeah, oxidation reduction reaction. Or in the brackets redox.
Okay.
Right. Then, so give me a second. As I said, primary alcohols you can oxidize up to here. It doesn't matter, right? You can oxidize up to here. When we goes to secondary, tertiary, this thing will change, right? So let's consider secondary one. Here 2R groups, right? 2R group means this is a secondary one, right? Because this carbon bonded with 2 carbons, right? Here this carbon bonded with only 1 carbon, right?
Yeah.
I just write the carbon to show it, right? Otherwise, writing R into here is enough, right? It's enough, okay?
Yeah.
Then we can oxidize this one up to this is ketone, right? What is the oxidation number now? Here, what is the oxidation number? This one. Here the oxidation number is 0, ne?
Yeah.
Here oxidation number is 0 and it goes to +2. Right?
Yeah.
We can't oxidize furthermore. This is ketone, we can't oxidize ketone furthermore. I mean, you can burn them, but not that kind of reaction, right?
Yeah.
The last option is combustion and
Yeah.
getting carbon dioxide, right? There's no any oxidation furthermore. This is secondary, yeah, this is secondary.
Mm-hmm.
When you go to tertiary, Cr, R and OH. What is the oxidation number now? It's +1. Eh?
Yeah.
Sorry, here it's not. Yeah, it's 0 and here it's 0. It's 0. Here it's +1. Right, it's +1. So you can't oxidize it further, right? No way to oxidize, right? Because this carbon bond, you can't remove that, right?
Oh,
Those are
okay.
CC bonds, right? The reason is carbon-carbon bonds,
Oh,
right?
okay.
We can't remove that carbon-carbon bonds and we can't oxidize. The only way is burn them and convert into carbon dioxide. It's different thing, right? But
Yeah.
no any regions to oxidize them, right?
Mm-hmm.
Even when they oxidizing, that carbon chain will change, right? I mean carbon chain, yeah, carbon structure, right?
Mm-hmm.
So this one you can oxidize this one up to ketone. Sorry, this aldehyde, and then this is carboxylic acid, right? This one secondary goes to ketone. That's it. So what are the regions? Let's talk about the regions. Huh? Um, um, this is oxidation reaction, right? So then what we have to use? What kind of regions we can use then? To oxidize something, what we use? We use
Oxygen.
oxidizing agents, right?
Yeah.
That's what we do, right? To oxidize someone, we use oxidizing agent. Ne? Similarly, right? I mean, in our normal day-to-day life also same, right? Agents, right? Oxidizing agent. To reduce someone, we use reducing agent, right? Reducing agent, we call them as reducing agent.
Yeah.
So what are the oxidizing agents that you know? The common oxidizing agents.
Um, like
Huh? What are the oxidizing agents that you know? If you remember someone, just tell. Oxidizing agent.
oxygen.
Okay, oxygen. Generally, I mean, we don't use, but theoretically correct. Oxygen, yeah. Oxygen can oxidize anything, right?
Yeah.
Nice answer. Right. uh, remember, okay, I'll give some. There are common strong oxidizers, right? Strong oxidizing agents. Strong oxidizing agents, right? Strong oxidizing agents, right? Those are, you may heard about that. Potassium permanganate, right? Potassium permanganate, KMnO4 at acidic medium. 1.
Yeah.
KMnO4 at acidic medium. As H+, right? Not only KMnO4, you need that medium.
Okay.
Then what else? Strong oxidizing agent and potassium chromate or dichromate, both correct. Huh? Potassium chromate, potassium dichromate, potassium dichromate slash H plus. And there's another one, CrO3 slash H plus. These are the common oxidizing agents that we use, right? Strong oxidizing agents. No, not the normal ones, right? They are strong one, right? So here, if we use strong oxidizing agent like this for primary alcohol, right? If we add strong oxidizing agent into a primary alcohol, it doesn't stop at aldehyde. It goes up to carboxylic acid, right? What did I say? If we use strong oxidizing agent to oxidize primary alcohol, it will oxidize up to carboxylic acid, right? So we can't get aldehyde in that case, right? We can't get aldehyde, but we can get carboxylic acid. If we use these for secondary alcohols, what will happen? It will stop at ketone because it can't oxidize furthermore, right? It will stop at ketone because it can't, right? Otherwise it will do. It can't, right? It can't, therefore it will stop at ketone. So you can use strong oxidizers to make ketone, right? But you can't use these for make aldehydes, right? Because though they are strong and oxidize it maximum level, right? They can oxidize it maximum level, right? So then how do we get alcohol? We can get alcohol, it doesn't in this part, but I will give it, right? There is a compound called pyridinium chlorochromate, right? It doesn't in your textbook, but like it may in the aldehyde and ketone part. Right. It isn't in your book, right? So therefore I don't give you to write, but remember there is another, we have some reagents to make aldehyde which is called pyridinium chlorochromate. We simply call it PCC, right? We just say PCC. That's also a oxidizing agent, right? But it's a light one, right? Not a strong one, right? It's a weak oxidizer, right? Another thing you should know, I said these are oxidizing agents, ne? They are oxidizing agents, ne? They are oxidizing agents. So during this process, what happened to the oxidizing agent? You know that compound will oxidize, ne? That compound will oxidize. So tell me what happened to the oxidizing agent? What happened to the agent?
It stays there.
Yeah, it stays there. Something happened to that.
Oh.
You know, I mean, in a reaction, in a redox reaction, only oxidation doesn't happen, right? Only oxidation doesn't happen. When oxidation happens, there should be a what? Reduction, right? When someone oxidizes, someone should
Oh yeah, they happen
Reduce.
together. Yeah.
Yeah. Someone have to reduce. Then which one will reduce here? This one, right? These are will reduce when they oxidize other one, right? That's what happened. These oxidizing agents reduce themselves and oxidize someone else. Understood?
Oh,
That's
yeah.
the basic, right? That's the basic. That's the very basic, right? So the opposite happen for the oxidizing agent, right? Opposite happen for reducing agent. In reducing agent, they oxidize themselves and reduce someone else. Clear, right?
Yeah. Mm-hmm.
You can define it, I mean, anyway, but the thing happen, they themselves here they themselves reduce and someone will oxidize, right?
Yeah.
They can oxidize someone else, right? They will reduce, right? Example, chromate. Here chromate ion, you know, do you know about these ions? Chromate, I mean, permanganate, haven't you
Oh,
learned?
I know them, but
Not deeply, right? I mean,
yeah,
I
I
guess,
just know. Yeah.
don't you have a lesson to learn about uh, D block, D block elements? I mean, in a periodic table, you know, I mean, there's a D block, right? S block, D block. I mean, we call inorganic chemistry. These
Last year
organics.
we just learned how to like read the SPDF notation, like 1s2, 2s2,
Uh huh.
2p6, like that. But we
Yeah,
didn't look at the
yeah.
elements.
That's under atomic structure part. Ne?
Yeah, but we
There is
didn't.
another. Huh?
No, we didn't look at the elements.
Right. Then it may have in next level. Ne? I mean, next means in university. After this level, you have to go to university. Ne? Actually, sometimes I mean, I don't know you. I mean, Australian structure, right? What do you
Yeah,
have to do after this?
yeah, university. But I'm not doing chemistry at university.
You don't know. You don't like that, right? It's hard, ne? Right. Um, so anyway, I mean, you don't need deep knowledge, but I mean, basic idea. This is strong. I mean, oxidizing agents will reduce themselves, right? So this MnO4, I mean KMnO4, this manganese. Here the oxidation number of manganese is +7, right? It will goes to +2, right? You don't need that, right? Just remember they are oxidizing agents and they do their work. That's it, right? So let's write down something. I explain each area. Right? Right. Write down the first sentence. Write down the first sentence. Primary alcohols has a oxidation oxidation no, primary alcohols first oxidize to form aldehydes 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 and then then further oxidize to form carboxylic acid further oxidize to form carboxylic acid further oxidize to form carboxylic acid further oxidize to form carboxylic acid. Write down the first sentence, right? Right, Cr2O7 slash H plus. The problem here, we can't stop the reaction after it's formaldehyde. So that's the problem, right?
Mm-hmm.
Otherwise it's okay, right? It's formaldehyde, then form carboxylic acid. I mean, during a conversion we can't use that, right? You don't have conversions, right? Just remember this. Huh? That's the example they given. Right. Next point, we can use other strong oxidizers also. 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 Other strong oxidizers also to do the same reaction. We can use other strong oxidizers also to do the same reaction. Right. Then leave a rule and write down. Other strong. Write down these two as example. KMnO4 slash H plus. Other oxidizers. Example for other oxidizers. Other strong oxidizers. KMnO4 slash H plus. And CrO3 slash H plus. You can do the same using these two.
Okay.
Right. Write the next reaction. No, sorry, next sentence. Leave a rule and write down. Secondary alcohols. Secondary alcohols. Secondary alcohols. Secondary alcohols only oxidize. Only oxidize to form ketones. To form ketones. 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 And 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 it doesn't oxidize, and it doesn't oxidize furthermore, and it doesn't oxidize furthermore. Write this example.
Okay.
This one,
Yeah.
right? um, so if they gave a compound and ask the product, right? So they don't give that, I mean, R, right? So they will give some carbon chain, right? I mean, C2H5, right? I mean, or something like that. So don't care about that part, right? We only care about this one, right?
Okay.
Check whether it's primary alcohol or the secondary alcohol, right? If it's a primary alcohol, it will goes up to, it can reach up to carboxylic acid, right? Oxidation. And if it's a secondary alcohol, it only
Just
oxidizes up to ketones, right?
yeah.
Clear?
Yeah.
Right. Then Leave a rule and write down. Tertiary alcohols are resist to oxidize. Tertiary alcohols are resist to oxidize. Resist to oxidize. Oxidize. And it can't oxidize. And it can't oxidize even using strongest oxidizing agents. Even using strongest oxidizing agents. Right. Here do mention it. I mean Cr2O7 2 minus slash H plus. I forgot it. And here Cr2O7 2 slash H plus. Dala and then cut it. Right, it doesn't happen. Clear? Is it clear? Ne?
Yeah.
Is everything clear up to here, up to now?
Yeah.
Right? No any is there any problem?
No.
Ask if you have anything.
Okay.
No, ne? This is easy, ne?
Yeah.
What are the parts that you? I mean, you said up to alcohol. Ne? I mean, your term test.
Oh, right. Wait, so actually we got our assessment notification. So we got the stuff that's going to be in the test. And it's up to, wait, I wrote it down. Oh, wait, do you want me to send you the notification?
Right. They send me.
You want me to send it?
No, you send nothing. I mean, you. No. I remember you said, like you said, up to alcohol or something.
Yeah, it's up to 7.5.3,
Mm-hmm.
which is a little bit past alcohols.
A little past alcohols.
Do you wanna, wait, do you have the syllabus with you?
Oh, yeah, I have syllabus pated. I'll check.
Yeah, so it's up to 7.5.3, but not A mines and amides.
Not amines and amides. Up to
5.3.
7.3.
7.5.3.
5.3. Organic acids and bases, ne? When do you have exam?
15th of June.
15th.
Yeah.
I mean, that means next month 15.
Yeah.
We have I guess we have 2 days, ne, before the exam. 15th. We have 2 weeks, ne? I mean,
Yeah.
then we can finish it. Seven. Next week 7. I mean 7, 14. Yeah, we have 2 days left
Yeah.
before the exam, so then we can cover that part. It's okay. We can cover that part. I mean next week we can finish that. This alcohol is almost over now.
Yeah.
Right. Then write down next reaction type: dehydration of alcohols. Dehydration of alcohols. Dehydration of alcohols. Dehydration of alcohols. Right. What is dehydration? What is
Removing
hyd?
water.
Uh-uh.
Removing water.
Removing water, exactly, right? Hydration means adding water. Dehydration means removing water, right? So here we remove one water molecule in an alcohol, right? One water molecule means it in alcohol group and one hydrogen, right? What happened here? This one, right? These two parts, right, of hydrogen and OH will leave. That means
Mm-hmm.
OH and hydrogen means water molecule, right?
Mm.
It will leave when what happened? It's make a double bond. C
Yeah.
C double bond, and it's release H2O molecule. This is what happened.
Mm-hmm.
Okay. So this type of reactions are called elimination, right? Elimination means, I mean, eliminate, removing, right? So we learn addition,
Mm-hmm.
substitution. This is elimination, right? Elimination, right? This is a new syllabus, but learn it, right? Elimination means removing, right? Removing and make a double bond, right? Simple, right?
Wait, what did you say? I can't hear you. Um, I can't hear you. Okay.
Can you hear me now?
Yeah.
Something wrong with the microphone, right? Right now, the dehydration is the dehydration reaction is removing water from alcohol molecule alcohol molecule removing water from an alcohol molecule alcohol molecule it produce CC double bond. It's produce CC double bond. It's produce CC double bond. I forgot the catalyst, right? So the catalyst that we use, reagent Al2O3 and Al2O3 catalyst and catalyst. You can use Al2O3 catalyst or conc, any conc acid, right? Conc acid, write it properly. Al2O3 catalyst or conc acid, right? Most of the time we use conc H2SO4, conc sulfuric, right? That's the common one. Here there are some temperatures also, but it doesn't in syllabus, right? So just write it Al2O3 catalyst or conc acid, whatever you like. Generally we use sulfuric as a conc acid. We add sulfuric and heat also required, but it doesn't mention here. Finish now? Right. Right. Then write down reaction of next type, reaction of alcohols with hydrogen halides. Reaction of alcohols with hydrogen halides. Reaction of alcohols with hydrogen halides. With hydrogen halides. Right. So here again this is a addition reaction. Sorry, substitution. Right. This is a substitution reaction. This OH substituted by this Br. Right. This OH substituted by Br. Simple reaction. We can substitute halogens by OH. Again, we can substitute OH by halogens. Both can be happen, right? We can do the both. So write a sentence. Alcohols undergo a substitution reaction. Alcohols undergo a substitution reaction in the presence of hydrogen halides to form alkyl halides and water. To form alkyl halides and water. So write these two. Sorry, not two. This one. Sorry, write this one. This is the reaction. Huh? Now, um, alcohol is over, right? Alcohol is over, but there is a part which is about fuel, right? It's not
Yeah.
about alcohol, but I mean it's contains some alcohol, but I mean the chemical and physical, those, I mean the important parts are over now, right? So now what I want to do, I want you to do that exercises in page number 332, and you can do the exercises again in page number 346 and 347. You can't do all the questions in 347, but you can do, right, half of the reactions. So
Yeah.
then that fuel part, it's not complicated, right? I mean it's contain that what that name, carbon emission, right? Carbon emission and some, I mean, different type of fuels and greenhouse effect, right? You may already know about greenhouse effect. Do you know about greenhouse effect?
Yeah.
Right. I mean, those are just general knowledge, right? I mean, I'll explain. No need to write anything also, right?
Okay.
Um, so yeah, that's it. So
Oh, okay. Thank you.
wait.
Yeah. Yeah. I'm just saying thanks.
wait.
Yeah. No.
What? හදිස්සි වෙන්න එපා.
No. There's no.
Right. Just joking. Yeah, it's almost wrong. Then next day we can finish that hydrogen part, and then yeah, next week we can start that acid and bases. Huh? Acid and bases. So I want you to just do the exercise and send me. Yeah, I mean otherwise, I mean I haven't marked the previous sections also, previous
A
exercise also.
PDF. Okay.
Yeah. Make a scan and make a PDF, right?
Mm.
Then I can check it and yeah. Otherwise, no way to check, ne?
Okay.
If you have any questions or I mean any hard questions, just send me and I'll explain. Okay.
Okay.
When you do the exercise, those are very small. I mean, very easy exercises, right? This kind of
Yeah.
things, or this kind of things in the exam, right? I mean, the
Yeah.
exercises like questions in the exam. No any hard
Yeah.
questions. Organic. The hard part, there are some the new parts in your paper. I mean, spectrophotometry, right? I mean, mass
Yeah. That's in
spectroscopy,
module A.
NMR. Huh?
That's in module 8. The next module.
Yeah, exactly. Right. So that part is the hard part, right? I mean, these are very easy, right? No any deep things, right? You can do it easily. So we had focus on that part. That's the. I mean, if it's is there any hard part? That's the hard part, right? This is easy. So do it and then actually you can do the. I mean, this fuel part, I mean if you read that it's enough, right? Not no any complicated things, right? Very basic idea here, right? Yeah, that's it. So do it, do it and send me, then I can mark it. Put the question numbers properly, yeah. And I
Okay.
mean otherwise I can't find it, find the question, right? No need to write the question, just write the answer with the proper question number, right?
Okay.
Yeah. So everything is clear up to now.
Yeah.
No any questions? Right. Okay. Okay. Now you can go.
Okay. Thank you.
Okay.
Yeah, bye bye.
Bye.